Thank you very much, Ricardo, for your enlightening presentation. On my side, I'll end this webinar with the related features and solutions provided by OPAL-RT. So we have a couple of features that are specifically designed for protection studies in a HyperSim. So we already have a virtual relay library comprising 7 different functions. And we do intend on the short term to add more functions to this library, specifically in the differential domain for generation, line differential, also in the distance domain, like the 21 quad function, for instance, also a directional overcurrent function that we intend to develop soon. We have also recently added the IEEE standard PMU model to our standard libraries. You've also seen in the previous presentations today the test automation tool that we have, TestView, that is great and easy to use to automate test sequences. It's also optional. We provide IEC 60255 pre-made test sequences. Presently we have the 121 test sequence for distance relay, and we also intend to add more pre-made test sequences that will be available as option to our real-time simulators. For those of you who like to program, we also have a detailed Python API that is well documented. And we also have a ComTrade playback module as a device in the modeling library that you can use to replay your ComTrade and have all the signals output from your simulator whenever you're connected to a protection relay. So some highlights I would like to recall for those of you who are less acquainted with real-time simulation. So our solutions cover a wide range of applications, so from individual relay and PMU testing to highly complex protection schemes in large networks. We can test either a single or multiple simultaneous events throughout the network at any level of the power system, whether it be generation, transmission, or distribution. In many domains, so renewable energy, microgrids, generation, and so on. Another very practical feature is that you can prepare your tests by simulating in offline mode on any laptop or desktop PC. So you don't need to be in your lab connected to your real-time simulator to prepare your model, run offline tests, prepare your test sequences with TestView, for instance. You can all do that on your own PC. And one big advantage of the closed loop testing is to consider the effect of the device under test on the grid. So you not only send values to the relay under test. So here, for instance, with sample values, it could also be through amplifiers with analog digital values. You don't necessarily only send values to the relay. You can also receive the response back from the relay that is going to impact the power system in your simulation, which in turn could have a various impact on the device under test for it maybe not to trip at a moment where you would expect that it would trip. So this is very important in testing protection relays and PMUs as well. You can interface with an unlimited number of IDs with our real-time simulator. We've run tests with 40, 80 data streams from sample value. You can have many relays interact with one another in a complex power system. And this can all be done with our real-time simulators. Another very important feature is the data logging. So you can log every single data point from any signal from the very first step of the simulation simply through a simple click, selecting the signal of interest, and then visualize your data and access a wide range of mathematical functions for deeper analysis in scope view. And then for the last part of my presentation, I'd like to introduce entry-level solutions that we are going to put on our website very soon in an e-commerce platform. So we have two solutions for protection studies. One that is based on RT-Lab, that is the most powerful solution for users of MATLAB Simulink and Simscape Power System. And we have the HyperSim-based solution that we recommend for the not MATLAB user. The main differences rely and with our bigger solutions in the entry-level network size. So to reduce the price, we limited the size of the network, which would be 90 single-phase nodes on one core, which is more than enough to simulate plenty of different applications. The model minimum time step lies close to the 3 microsecond range. If you add control in the loop with IOs, this goes up to close to 5-6 microseconds. If you do want to play ComTrade files back, it's easier to do it with the HyperSim solution. As I've presented in a previous slide as well, we also have a specialized test automation tool that is TestView, that is only compatible with HyperSim. Optionally, in TestView, we provide IEC 6255 protection relay testing sequences. So in terms of technical specification for the chassis, we use the same chassis for both solutions. So it's an OP4510 that boasts 4 cores Xeon E5 processors at 3.5 gigahertz each. You can have up to 4 I/O cards. This is flexible, but typically you would have 32 analog output, 32 analog inputs. 16 analog outputs, 16 analog inputs, 32 digital outputs, and 32 digital inputs. Optionally, you can add a time synchronization kit to connect to a GPS clock, for instance. This is specifically useful if you have a communication protocol that needs to be time-stamped. So in terms of communication protocols, we support pretty much all the communication protocols that are relevant for this industry. So IEC 61850, C37118, DNP3, Modbus, even more SCADA protocol, for instance, such as OPC-UA or IEC 6870-5-104. Those are simply a couple of examples. We support even more. And on IEC 61850, as presented earlier in the presentation by Romain, we also have the sample value data integrity manipulation that is available as an option in both packages. So going back to the main point here is the low cost at which it starts. This applies for US and Canada only. So for educational, the RT-Lab platform starts at 22K, and for industrial, it would be at 29K. And HyperSim also starts at 22K for educational and 30K for industrial customers. So that I added the third column here to also show what we're capable of. If this is not enough for your application, you need a bigger network than 90 single phase nodes. You can actually have an unlimited size network with our bigger simulators. I go up to 96 cores Xeon E5 or E7, on which you could have up to 8 I/O cards in a single chassis, but to which you can add additional chassis for more I/Os as expansion boxes. So this is based on our OP5000 family. And this also enables the FPGA simulation that we've presented for the traveling wave testing, for instance. You can go at a time step down to the 125 nanosecond range. And this also provides all the other optional features that we have in the entry-level packages, so the time synchronization kit and multiple communication protocols. So to get a price that is tailored to your application for this range, you'd have to call us. So that will be all for me today.